Eso me para guau, 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 guau. When you walk out, la, 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 la. When the cat from my ta, 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 ta.
Yeah, okay, you need to get done, 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 done. At work, come over. We just need to slow the motion. Don't get out of the way to no one. Long distance, I need you. When I see potential, I just gotta see it through. If you had a twin, I would still choose you. I don't wanna rush into it if it's too soon, but I know you need to get done, 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 done. If you come over, sorry if I'm way less friendly. I got niggas tryna end me. Oh, yeah. I spilled all my emotions tonight, I'm sorry. Rolling, 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 rolling. How many more shots until you're rolling? We just need a face to face. You could pick the time and the place. You'll spend some time away. Now you need to forward and get me out of work, 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 work.
It's me up there, work, 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 work. You see me do my da, 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 da. So me para guau, 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 guau. When you walk out, la, 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 la. When the cat from my ta, 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 ta. Work, 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 work.
Okay, good afternoon, everyone. Right, so welcome back after holiday. All right, last week. So, all right. So today we going to continue about what we discussed last week. All right. So last week kita discuss berkenaan register. All right. So you know that register is inside the CPU. So dia ada beberapa function. Alright, dia ada beberapa function. Yang mana kita dah belajar last week, ada function as accumulator. Alright, so dia maksudnya daripada memori, dia akan CPU tu akan bawa data from memory, access the data from the memory, akan bring to the register untuk membuat pengiraan. Alright, so either you want to move ataupun addition, alright. And then dia ada beberapa jenis register lah, alright. So dia ada general, pointer, index, segment, instruction and flag, yang mana yang kita dah belajar pada minggu lepas. Alright, so hari ni kita akan continue. So last week kita dah belajar berkenaan register, general register, okay, yang belakang dia ada X, alright, and then ada H dengan L, okay, and then hari ni kita akan tengok kepada segment register. Okay, so apa function segment ni? Okay, and then after this, okay, saya akan adakan satu quiz, alright, saya akan adakan satu quiz. So which we will take time after 10 minutes break. Okay. So after we finish discussion on this, then maybe around 5 p.m. So and then we take a break for 10 minutes and then we will have a quiz. So quiz tu ada 5 soalan. So berkenaan apa yang kita dah belajar sebelum ni lah. Alright. So about the get logic and so on. Okay, so it's simple, just 5 questions quiz. Okay. And then you can refer to any notes. Okay, so sebarang soalan sebelum saya start? Okay, so ada soalan, so saya akan teruskan dengan segmen register. Okay, so ini kita dah belajar lah dengan move and add instruction untuk kita add two numbers, alright, and then that numbers we put into the register, so we add two register. Okay, so we will get the result. Yes, Ruben, you have any question?
No, doctor. My microphone suddenly turned on.
Okay, no problem. Okay, alright, so we look into the program segments, okay. So a typical assembly language program consists of at least 3 segments. Okay, so dia ada micro register, so kita ada code segment, okay, which contains the assembly language instruction that perform the task that the program was designed to accomplish. Right, so assembly language ni dia akan ada beberapa instruction macam move tadi, move, add, so itu instruction assembly language. Okay, so segment ni dia akan bahagikan untuk diletakkan dia punya instruction tu lah. Alright, so instruction tu diletak dalam this code segment. Okay, so bila dia nak recall balik, so dia just refer kepada this code segment. Okay, so itu berkenaan code segment, maksudnya dia ada beberapa instruction yang diletak dalam that segment, and then so you boleh recall balik. Okay, untuk you baca what is inside the general register, or you want to perform the operation. Okay, and you ada juga data segment. Okay, so data, so you usually data you use to store, alright, store information to be processed by instruction, okay, in the code segment. Okay, so you ada code. Okay, code is where the instruction lies, and then you have the data. Okay, so instruction kena pair dengan data. Okay, so you nak instruct apa? So you must instruct the data to do what you want it to do. Alright, so you nak suruh data tu buat apa? Okay, and then we have another segment called that as a stat segment. So stat segment is used by the CPU to store information temporarily. Okay, so it's like a temporary memory lah. Okay, so dia sama juga macam data segment, tetapi digunakan untuk temporary sahaja. Okay, so itu 3 segmen yang sekurang-kurangnya kena ada dalam CPU. Okay, so a segment, okay, so ini definition segment. A segment is an area of memory that includes up to 64 kilobytes and begins on an address evenly divisible by 16. Okay, so maksudnya digunakan base 16 lah, hex numbering. Okay, so maksudnya dia punya capacity up to 64 kilobytes. Okay, so bila you ada 64 kilobyte, maksudnya berapa actually you punya capacity. Alright, so 8085 address a maximum of 64K of physical memory. Okay, 8085 ada maximum dia boleh 64K of physical memory. Okay, because dia ada 16 pins of address line. Okay, so 64, so kalau you tengok kepada binary, okay, binary numbering, so you can store up to 16 bit lah, right, 16 bit. Okay, so you ada from 20, okay, 20 to 15. Okay, So you ada 64K of memory. So limitation was carried in 286 design for compatibility. Okay, so in 85 there was 64K bytes of memory for all code, data and stack information. So dia ada ketiga-tiga segmen ni. Alright, so you jadi at least dia kena ada 3 segmen, which is code, data and stack segment. Okay, so perbezaan dia dengan 86, they can be 64 kilobytes in each category. Maksudnya every code tu ada 64K, data ada 64 and stack ada 64. Kalau 85 dia ada 64 untuk kesemua tu. So maksudnya kalau kod gunakan semua 64, so tak adalah space untuk data and stack. Okay, so if you want to use that, alright, if you want to use that space, okay, for data or stack information, so you must first flush, okay, the information yang dah dalam tu, so you can accommodate the space. Okay, so that's the difference between 85 dengan 86. Okay, give me 10 seconds. Okay, alright, in the literature concerning 86, there are 3 types of addresses mentioned frequently. Okay, so dalam program segment ni, okay, so you kena, so it's because it's like a memory, so you kena ada address. Okay, first before you access the data, so you kena ada address. So macam kita belajar sebelum ni, so first CPU akan tengok kepada address. Okay, once dah jumpa the address, and then barulah dia boleh tarik that data. Okay, so the physical address, so dia ada physical address, and then another one is logical address. Okay, so what is the physical address? Okay, so physical address is the 20-bit address actually on the address pins of the 86 processor decoded by the memory interfacing circuitry. Okay, so dia boleh ada range dia, okay, from 000000 up to FFFF. Okay, so dia punya capacity, alright, so is between, right, 16 to 0 to 16 to 5. Okay, so you add semua ni, so you boleh add lah dia punya capacity. Alright, so the actual physical location in RAM or ROM within the 1 megabyte memory range. So the capacity is about 1 megabyte. Okay, so daripada part of the physical, okay, kita ada juga offset address. So macam saya cakap tadi, ada logical address. Okay, after this, we will look to what is the logical address. Okay, so physical address, tadi address pin yang dah ada, alright, pada that processor. Okay, so dia decoded by the memory interfacing circuit. Okay, and then we have an offset address is a location in a 64 kilobyte segment range. Okay, also dia ada range juga. Okay, this one is between 000 to FFFF. Okay, so dia kurang, okay, 1 bit daripada that physical address tadi. Okay, so yang ni kita ada 416 bit punya ni lah address. Okay, so yang tadi ada 16 apa ni, 16 bit punya address. Okay, and then we have the logical address, which consists of a segment value and an offset address. Okay, so logical address is part of the offset address. Okay, is the logical address. Okay, so to execute a program, 86 fetches the instructions, okay, opcodes and operands from the code segment. Okay, so opcode is tadilah. So macam move AX, right? So move tadi is the opcode and operand is AX. Okay. So sekarang ni CPU wants to execute a program. Okay, so we have a program, so we already written that program. Okay, so now we want to have that CPU execute that program. Okay, so dia akan fetch the instruction, okay, from the code segment. Okay, sebab saya cakap code dia ada instruction, so mesti dia bergantung pada instruction. So dia tengok apa instruction tu. Alright, so once dia dah tengok that instruction, okay, then the logical address of an instruction always consists of a CS, okay, which is the code segment, and an IP. Okay, so dekat sini dia ada dua register yang terlibat, which is first is segment register and also pointer based register. Okay, so yang code segment tadi, is the code segment, okay, which involve and then an instruction pointer. Okay, so dia punya format dia dalam bentuk CS double.IP. Alright. Okay, so the physical address for the location of the instruction is generated. Okay, tadi dia dah ada logical address. Okay, now we want to look into the physical address. Okay, so physical address for the location of the instruction is generated by shifting the CS, okay, code segment left one hex digit, then adding it to the IP. Okay, so tadi dia dah ada logical address. Okay, so daripada logical address kita nak obtain the physical address. So cara dia buat is kita shift the code segment tu to left one hex digit and kita tambah kepada IP tadi. Alright, instruction pointer. Okay, and then IP ni dia ada the offset address. Okay, so yang dia punya result, okay, so tadi you start dengan logical address, ada physical address, and then IP tu part of the offset address, and then the result dia, alright, you ada 20-bit address. Okay, so it's called the physical address. Okay, since it is put on the external physical address bus pins. Okay, so yang ni lah, yang physical address ni yang bus yang diletakkan pada real CPU punya location. Okay, kita tengok pada contoh. Alright. Okay, contoh. Alright, kita ada code segment, dia punya address is 2500. Okay, and instruction pointer, we have 95F3. Okay, so dia punya capacity you boleh pergi up to FF lah. Okay. Alright, so offset address tadi, apa value dalam IP tadi? Alright, instruction pointer. Okay, which is 95F3. Okay, and then kita ada logical address CS double.IP. So you baca from 2500 double.95F3. Okay, so that is the logical address. And physical address, apa yang saya beritahu tadi, so you must shift. So you shift 1 CS, okay, to the left, okay. So bila you shift, okay, so you shift 2, 5, 0, 0. So belakang tu akan jadi 0 lah. Okay. So you have 25000 and you add with the IP. Okay. So once you add, so you akan dapat this value. Okay, 0 plus 3, 3, okay, F, okay, F5, okay, and then 5 plus 9, okay, we dapat 14, right? So 14 apa dia punya code? E, right? And then 2, okay? So that is your physical address. Okay, so if kita nak kira the physical address, okay, so apa yang penting kita kena ada code segment, right? So code segment yang menunjukkan the initial address, okay. So and then kita kena ada IP, alright. So ini contoh sama macam tadi lah, alright. So you shift to the left and then you akan ada kosong dekat belakang. Okay. So once you dapat the final address, which is the physical address, so the microprocessor will retrieve the instruction from the memory location starting at 2E5F3. Okay. So dia akan start retrieve the instruction from this memory location. Okay, so itu instruction yang dia nak ambil lah daripada that memory location. Okay, so since IP can have a minimum value of 0000 and a maximum of FF, alright, the logical address range in this example is, so you ada 2500 double dot 000 to 2500 double dot FF. Okay, so yang tu maximum range lah. Okay, so that's the maximum range of the logical address. Okay, using that IP instruction pointer. Okay, so kalau you nak convert to the physical address, so sama juga macam tadi, berapa actually minimum yang boleh dikata oleh the physical address and then the maximum value. Okay, so kalau you add tadi, so you kena shift kan, kena shift 2500, dia akan jadi 0, another one, and then plus 000 lah. Alright, so the lowest memory location, maksudnya lowest physical address is 25000, okay, and then highest memory location, so you shift 2500 tambah satu lagi 0 and then you add with F. Okay, so F plus 5 yang kat sini, okay, so F plus 5, so you dapat berapa? So F is 15, okay, you add another 5, so that is 20, so 20 minus 16, okay, so you dapat 4, okay, so you add 1, so 3, 4, F. Okay, so that's the range lah. Okay, so that's the range of the physical address. Okay, katakan you punya instruction, okay, tak ada dekat situ. Okay, so maksudnya it's not within that boundary. Okay, dia luar daripada tu. Okay, so macam mana you nak access? So you kena tukar the value CS tadi, okay, to access those instruction. Okay, alright, kita tengok pada another example. Okay, katakan CS is 24F6, alright, and IP is 634A. Okay, first kita nak cari logical address. Okay, So what is the logical address? So logical address, you just combine CS_IP. So that is logical address, which is 24F6_634A. Okay. And then the offset address. So offset address is the address of IP, instruction pointer. So you dapat 634A. Okay. And physical address, so you kena shift yang CS tu to the left, and then you add 0 at the back, and then baru you add with IP. So you akan dapat, okay, macam ni. Alright. 2B2AA. So you tambah sini kan, so you dapat A. Alright, and then 6 plus 4 you dapat 10, which is also A. Okay. And then you have 3. 3 plus F. 3 plus F you dapat 18. Okay, so 18 minus 16 you dapat 2. Okay, and then you kena add 1. Okay, you bring forward 1. So 1 you add dengan 4. Okay, 5 tambah 6, 11. So 11 is equivalent to B. Okay, and then 2 lah kat depan. Right, so this is the answer. Okay, so tu you punya physical address. And then what is lower range? Okay, and upper range of the code segment. So lower range tadi, so kalau you nak tengok dari segi dia punya physical address, okay, so kena tengok daripada dia punya physical address, you kena shift ni to 4F60, and then you add with 000 lah. So of course you dapat balik this number 24F60, and then upper range, so you add with FFFF. Okay, so once you add with FFFF, you can dapat 34F5F. Okay. Alright, so now you tahu macam mana nak dapatkan the logical address, offset address, and also the physical address. Okay. So yang penting sekarang ni is daripada code segment. Okay, daripada code segment you akan dapat those addresses. Okay. Okay, in the next code segment, okay, CS and IP hold the logical address of the instructions to be executed. Okay, so kita akan dengar the following assembly language instruction has been assembled, okay, translated into the machine code and stored in the memory. Okay, and the 3 columns, so the logical address of CS IP, the machine code stores at that address, and the corresponding assembly language code. The physical address is put on the address bus by the CPU, okay, to be decoded by the memory circuitry. Okay, so once you dah ada that logical address, so you kena translate that to the physical address. Okay, so but physical address tu actually the real location, kat mana dalam memory tu you nak cari. Okay, so once you get that, so that data can be put on the address bus, so letak dalam atas highway, and then barulah boleh dia decoded by the memory circuit. Okay, so kita kalau code, alright, so of course kita akan gunakan assembly language. Alright, so macam ni lah macam yang kita belajar, so kita code macam ni, but macam mana machine tu nak faham apa yang kita code, so dia kena translate. Okay, so dia kena translate kepada dia punya code macam ni. Alright, macam ni, you ada move AL57, maksudnya you want to move 57 to that AL. Okay, so dekat sini you can see that, so that information of 57 still retain, except yang depan ni berubah lah. Okay, so dia nyatakan this one is the B0. Okay, and then you ada another value. Contoh, if you start this dekat this location 11320100, so dia akan increment every increment by 2. Okay. Alright, so next contoh kita ada move 86 to DH. Okay, so still 86 is written here, except that depan ni jadi B6. Okay, because that depends on the register that we use. Okay. Alright, and then we have DL. Okay, sorry, 72 you put into the DL, and then we have B272. Okay, and then move DX into CHX. Okay, so because this one, okay, this one you don't have the value, kita ada value. Okay, so that's why dia punya ni akan jadi macam ni. Okay, akan jadi D1. Okay, alright, and then you move AL into BH. Okay, so this one dia akan berubah lah. Okay, so now dia akan jadi A8C7. Okay, so kat sini dia dah tak follow. Alright, yang belakang tu sebab sekarang ni belakang dia dah berubah. Okay, alright, and then we have 9F into the BL. Okay, and ini still retain belakang ni sebab you tak move. Okay, you tak move the variable but you put the value. Okay, so AH20 pun sama, so you still retain the value, and we have DX into the AX. Okay, so untuk DX ni, okay, so dia initialize kat sini as D0, and then BX into the CX. Okay, so that they initialize the machine code as 01D9. Okay, so this one dah tak follow lah. Okay, and AX1F35. Okay, so for this one, alright, so it has the different code lah untuk the machine language tu. So kalau tadi 1F35, yang ni dia terbalikkan. Okay, so now it becomes 05351F. Okay, so dekat depan ni, alright, so dekat depan these two at the front, okay, is the opcode. Okay, so ni dia punya code lah untuk perform apa-apa operation, okay, melibatkan every different variable. Okay, so tu cara macam mana komputer baca, right, that assembly language. Okay, ada sebarang soalan? Okay, so kita tengok a little bit detail. Tadi kita dah tengok. Alright. Kasi machine code dia B057. Okay. So kita tengok. Kita nampak kat sini. Dia akan add 222. So what happened at 1132.0101. Okay. So ni lah yang berlaku. So actually because that pair, Okay, dia ada opcode and operand. So sebab tu dia kena sentiasa add 2, 2 and 2. Alright. So dekat sini dia punya physical address is, so macam ni nak tahu physical address. So dia tambah lah. Okay. 11 you shift dulu. 11 is 320. You add with 0100. So you akan dapat this one. Okay. Okay, so sekarang B057 ni tadi dia punya instruction is to move. Okay, to move 57 to AL. Okay, so the byte address, okay, 11320100 contains BO. Okay, so yang atas ni contain dia punya opcode, and then yang bawah ni contain dia punya value lah. Okay, so opcode dengan operand, opcode dengan operand. So that's how the CPU operates. Okay, kita tengok for one example. So assume a program to add 5 bytes of data such as 25, 12, 15, 1F and 2B. Okay, so the way to add them is as follows. Okay, so ini kita tambahilah semua benda. Alright, so add 0 to AL and add 25 to AL, add 12 to AL and add 15 to AL and so on. Okay, if the program above, the data and code are mixed together in the instruction, okay, if the data changes, the code must be searched, okay, for every place it is included and the data retype. Okay, so maksudnya sekarang kita nak tukar data. So nak tukar, of course lah kita kena cari location of the data and then barulah kita boleh retype that data. Okay, from this arouse the idea of an array of memory stick, okay, for data. Okay, so daripada sinilah the researcher dapat idea untuk right, untuk membuat satu kawasan lah, satu kawasan area or space untuk memory stick. Okay. Okay, tadi kita dah bincang pada code segment. Alright, code segment apa, macam mana you nak tentukan the address, physical address, apa ni, logical address and offset address. Okay, and then kita tengok kepada data segment. So the data segment uses register DS and offset value. Okay, so the debug assumes that the number are in hex. Okay, so tak perlulah you nak type the H2. Alright, so they assume that number is already in hex. Okay, but MASM assume that they are in decimal. So you, kalau you pakai the different assembler, so the way to type is also different lah. Okay. Okay, so kita akan tengok pada how data can be stored in the data segment and the program rewritten. Okay, so that it can be used for any set of data. Okay, assume that data segment of sets begins at 200H. Okay, the data is placed in memory location. Okay, so ni dia punya apa ni, machine code kan, right? So machine code is 2512. Okay, and then it stops after 2B. Okay, so inilah data, okay, yang use the space inside the memory location. So dia start dekat 0200. Okay, so the program can be rewritten like this. Okay, so you have 0. So you put into AL. Okay, and then so you boleh gantikan dengan bracket. Okay, this data. Okay, so sekarang ni you nak masukkan the above data tadi, ds double dot 02000201 semua tu. So you boleh gunakan this command. Alright, so just put the bracket, and then call the IP dia, IP punya number, instruction pointer punya number, and then you boleh tambah lah terus, alright, to your system. Okay. Alright, so the offset address is enclosed in brackets, which indicate that the operand represents the address of the data and not the data itself. Alright, so macam yang saya cakap tadi, you gunakan that bracket. Okay, so if you want to or you call that, use that tadilah, use that value dalam data segment tadi. Alright, dalam data segment tadi. So tadi you dah belajar berkenaan that code segment, right? And then data segment is your data lah. Alright, is your data, is the value itself. Okay, so sekarang kita tengok pada location 2512 and 151F and now 2B, and yang kalau tu dia akan jadi 2B00. Okay. Okay, so kalau katakan you buang that bracket, okay, so you buang that bracket, you tak panggil lah that data segment tadi. Alright, so dia akan panggil that number saja, right? That number yang mana you tak panggil the variable inside that. Maksudnya kalau ikutkan you punya result sekarang ni AL, kalau you buat macam ni, alright, so move AL comma 0200. So your punya AL is 0200 lah, alright. Kalau you buat macam ni, so you punya content of AL will be this one, okay, 25. Okay, so dia tak akan sama. Alright. Okay, if the data had to be stored at a different offset address, okay, the program would have to be rewritten. Okay, a way to solve this problem is to use a register to hold an offset address. Okay, before each add increment the register to access the next byte. Okay, seperti tadi kita kena ada satu tempat temporary lah. Okay, so kalau you nak pakai kalau you still nak pakai data. Okay, alright. So you kena pakai another register. Okay, so ketika you dah panggil tapi you tak nak add dulu. Okay, you nak store kat mana? Kalau you panggil, okay, you add terus, okay lah, sebab you gunakan terus. Tapi you panggil, kita move. Okay, move this value to this, move this one and move this one. So dekat situ where we kita akan gunakan, okay, use the register of BX, SI and DI as offset register for the data segment. Okay, so the term pointer is often used for a register holding an offset address. So kalau you nak tadi you move, okay, so you nak hold that one, so you kena pakai pointer lah. Okay, so you kena pakai pointer. So you ada tadi you ada IP and so on, so you ada another yang belakang ada P tu, dia punya register P. Okay, so dekat sini, alright, so kalau ikutkan 86 punya processor ni, you kalau nak hold, alright, you boleh gunakan either BX, SI and DI. Okay. Alright, so sekarang ni, okay, now kita tengok to the example. Okay, kita tengok to the example. Okay, now move AL 0, so AL becomes 0, and then move BX. Okay, BX 0 to 0, 0. Okay. Okay, 0 to 0, 0. Okay, sekarang ni dia punya content BX is 0 to 0, 0. Okay, and A is 0. Okay. And then add the first byte to AL. Okay, maksudnya sekarang dia akan access the content with the bracket kan. So dia akan access the content of 0 to 0, 0. Okay, bukan dia access, dia akan add the value tu. Dia akan access the content of the 0 to 0, 0. Content tu yang akan di add to AL. Okay. So sekarang BX tak digunakan. Alright, BX tadi tak digunakan. Tapi dia punya address tu digunakan. Okay. Sekarang you nak increment BX. Sekarang baru you nak guna. Sekarang you nak guna, so increment dia akan tambahlah 1 to that BX. Okay. And then dia panggil lagi yang lain. Okay, still you tak guna. Alright, that content BX. You cuma, so now you punya BX is dalam bracket tadi is AL, add AL, comma, in the bracket 0 to 01. Okay, 0 to 01. Okay, and then you increment again, and then now add content AL tadi. So you dah add tadi, AL tadi dah ada value. Alright, and then you add lagi AL. So dia akan increment lah sebab dia punya address tu berbeza-beza. Okay, so you tak add the same the same address of that data segment tadi. Okay. Alright, so sekarang ni, so you add different value. Okay, dekat sini different value. AL contoh kat sini kan, dia access content 0 to 0, 0. Okay, sebenarnya dia punya value is for example 1100. So dia add lah 1100 ni. Okay, sekarang ni 0 to 01. Apa lagi content dia? Contoh content dia is tadi 11. Ini this one is 1101. So dia add lah 1101 to 1100. Okay, so dah berapa? So dia akan dapat 2201 for example. Okay, so I mention this in the hex value lah. Alright. Okay, and then you add lagi, you add sampailah the final stage. So you akan dapatlah summation of that value yang you add to that AL. Okay. Okay, so you ada function increment tadi. So macam saya cakap, you increment tu you add 1 lah. Alright, so you add 1. So dia sama juga macam result add BX 1. Okay. So if the offset address where the data is located is changed, only one instruction will need to be modified. Okay. Okay, so the physical address for data is calculated using the same rules as for the code segment. Okay, so the physical address of data is calculated by shifting the DS left 1 hex digit and adding the offset value as shown in this example. So macam CS code segment tadi juga, untuk data segment, alright, kita gunakan cara yang sama lah. Okay, kalau you nak kira that physical address of that data segment tadi lah. Right, tadi kita dah buat untuk code segment, and then now kita nak buat untuk data segment. Saya cakap tadi, so you punya code tu contain all of the instruction. Data, you punya data lah, dia punya value tu. Okay, so this is how you do it. Okay, this is how you do it. Okay, so you ada 5,000, so you shift, you akan jadi 5000 and 0, and then you add with the offset address 1950, and then you add, you can get the physical address. Okay. Alright. Okay, so let's take a break for 10 minutes, and okay, so kita stop dulu. Alright. Discussion about that. Tadi kita dah discuss about the code segment, and then kita dah discuss about the data segment. Okay. And then related dia punya offset address, and also the physical address, and also the logical address. Right. Okay, so let's take a 10-minute break. Okay. And then after that 10 minutes, saya akan run a quiz. Okay. Which will be 5 questions only. Alright. So 5 soalan je. So it will be based on the previous topic yang get logic tu. It's very simple one. Okay, so ada sebarang soalan tak?
Doktor,
Yes.
soalan dekat 13 ke?
Bukan. Saya letak dekat Quizit nanti, and then you can access after this.
Okey.
Okay.
Doktor,
Yes.
kan dia kena shift kan? Tu dia pada 5000 dia jadi tambah kosong kat belakang. Tapi kenapa kita still gunakan 0000? Kenapa tak jadikan 5 juga?
Tak jadikan 5?
Maksudnya 000, dia tetap 16 bit juga
Dia still ini dalam bentuk 16 bit. Okay, tadi sebab you tengok tadi yang asalnya, you tengok tak yang ni, yang masa dia punya ni, sebab dia punya content ni, physical address, dia punya range dia from 0, dia ada 5. Okay, 5. 00000 to FFFFF. Ini tadi. Beza dia dekat sini. Alright, this one. Okay, dia physical address. Okay, the address ada range dia 5 ni. So 00000 FFFFF. Okay. And then offset address dia ada 4 je. So tu beza dia. So you nak translate ni, so offset ni part of the physical address sebenarnya. So you add, you tambah. Okay, so barulah you boleh dapat that physical address tu.
Okay.
Alright. Okay, any more question? Okay, so alright, so ada soalan. Okay, kita take break, and then kita akan start balik 5:20. Alright, so we'll start the quiz at 5:20. Okay, see you at 5:20.
Okay, doktor.
You know I want you. It's not a secret I try to hide. You know you want me.
So don't keep saying our hands are tied. You claim it's not in the cards, and fate is pulling you miles away and out of reach from me. But you're here in my heart, so who can stop me if I decide that you're my destiny? What if we rewrite the stars? Say you were made to be mine. Nothing could keep us apart. You be the one I was meant to find. It's up to you and it's up to me. No one can say what we get to be. So why don't we rewrite the stars? Or maybe the world could be ours tonight.
You think it's easy? You think I don't wanna run to you, yeah. But there are mountains, and there are doors that we can walk through. I know you're wondering why, because we're able to be just you and me within these walls. But when we go outside, you're gonna wake up and see that it was hopeless after all. No one can rewrite the stars. How can you say you'll be mine? Everything keeps us apart, and I'm not the one you were meant to find. It's not up to you, it's not up to me. When everyone tells us what we can be, and how can we rewrite the stars? Say that the world can be ours tonight.
All I want is to fly with you. All I want is to fall with you. So just give me all of you.
It feels impossible.
It's not impossible. Say that it's possible. How do we rewrite the stars? Say you were made to be mine, and nothing could keep us apart. 'Cause you are the one I was meant to find. It's up to you, it's up to me. No one can say what we get to be. Why don't we rewrite the stars? Changing the world to be ours.
You know I want you. It's not a secret I try to hide, but I can't have you. We're bound to break and my hands are tied.
You know I want you. It's not a secret I try to hide. You know you want me. So don't keep saying our hands are tied. You claim it's not in the cards, and fate is pulling you miles away and out of reach from me. But you're here in my heart, so who can stop me if I decide that you're my destiny? What if we rewrite the stars? Say you were made to be mine. Nothing could keep us apart. You be the one I was meant to find. It's up to you and it's up to me. No one can say what we get to be. So why don't we rewrite the stars? Or maybe the world could be ours tonight.
You think it's easy? You think I don't wanna run to you, yeah. But there are mountains, doors that we can walk through. I know you're wondering why, because we're able to be just you and me within these walls. But when we go outside, you're gonna wake up and see that it was hopeless after all. No one can rewrite the stars. How can you say you'll be mine? Everything keeps us apart, and I'm not the one you were meant to find. It's not up to you, it's not up to me, when everyone tells us what we can be. And how can we rewrite the stars? Say that the world can be ours tonight.
All I want is to fly with you. All I want is to fall with you. So just give me all of you.
It feels
But it's not impossible. Say that it's possible. How do we rewrite the stars? Say you were made to be mine, and nothing can keep us apart. 'Cause you are the one I was meant to find. It's up to you, it's up to me. No one can say what we get to be. Why don't we rewrite the stars? Changing the world to be ours.
You know I want you. It's not a secret I try to hide, but I can't have you. We're bound to break and my hands are tied.
Okay, welcome back. Alright, so I will open the link for the quiz shortly. So you can refer to any notes and books, right? Okay, so you can go to that link and then enter join code. All right. So I will wait for 1 minute and then we will start. Okay, we got the first participant. So mana yang lain?
Kejap doktor.
Okay, ada alright 10. One, two, three, four. So dekat sini ada 19. So where are the rest? Kita ada now we have 13. Alright. Okay, I will start from 10. Okay. 10, 9, 8, 7, 5, 7, 6, 5, 4, 3, 2, and 1. Okay, saya akan stopkan quiz within 1 minute because most of us nak jawab kan. Susah ke quiz ni? Ramai tak boleh dapat. Atika, okay. Apa yang awak nervous?
Ingatkan ada masa rata.
Apa dia?
Ingatkan ada masa. Lepas tu tak
Ada masa.
laju-laju, lepas tu salah.
Simple je kan soalan dia. Okay, I'll start the quiz now. Mana yang lain tak dijawab dulu masa ni. Okay, congrats to the top 3. So kita akan tengok. Alright, kita akan tengok over soalan. So you guys dah dapat kan dia punya answer? 83 you just buat ni lah. Okay, so dia punya answer is kenapa ada 00, ada 1 kat sini. So 8 kan, 2 2 3, 1 0 0 0 and 3 0 1 sorry 0 0 1 1 lah. Right, yang ni you silap satu je ni. Semua buat
Kenapa doktor?
Kenapa ramai buat 1010 lah? Sepatutnya 100 and 0011. Okay. Alright, yang ni kepada hex. So yang ini berapa kalau hex? Yang ni kan berapa ni? C right? Yang ni?
2.
2.
Nervous juga.
Okay.
Doktor tadi tu
Ha?
2C ke 3C?
Sekejap. Yang ni tadi sekejap. Yang ini
3C lah.
ingin
Yang tu C.
berapa?
C. Yang belakang tu kan?
Tak, yang ni 8, 9, 10.
3.
Betul lah 3. Sorry, this one I silap. Okay, 3C. Sepatutnya 3C lah. Okay. And then this one. Panjangnya jawab. Okay, buffer. So you tengok buffer kan yang ada line tu yang pergi ke dia punya logic gate. Alright. Not dia akan change. Alright. Kalau not dia akan ni lah inverse lah. Kalau 0 mana ada not gate ke? Tak ada kan? Nor or XOR mana ada not? Inverter dia lah. Mana you dapat not ni? Hamai juga jawab not. Okay. And ALU. Okay, ada multi logic unit. Ada typo kat sini. Should be okay. Alright. Address bus. Okay, betul. Macam-macam jawab. Ada microcontroller bus ke? Kan saya ajar ada 3 bus je. Alright. Ada address bus, ada data bus, dengan satu lagi control bus. Okay, so you have only 3 choices. So yang penting is address bus dengan data bus lah. Alright. Dah ada bus, you jawab bus lagi. Letak address je lah. Okay. Alright, tak apa. Okay, nanti kita akan next week kita akan ada second quiz. Alright. So that one I will make about 10 questions. Okay. So the material apa yang kita belajar starting from ni lah. Okay. Today and yang also last week tu. Okay, so your a bit of information. Okay, sebab today hari ni saya beritahu pada macam minggu lepas. So kita akan gantikan 1 jam untuk minggu ni and then another 1 hour untuk next week. Untuk gantikan kelas pada holiday last week. Alright. And then kita akan ada kelas macam biasa 2 jam on Thursday. And then your test 1, okay, so your test 1 saya akan buat pada hari Khamis, okay, minggu ke-6. So week 6. So this week is week 4, right? Okay, week 4 and then we have next week, week 5 and another week. Okay, so the date, so week 6 is on the 25th, okay, 25th of November. Okay, tu you punya date of your test 1.
Doktor sampai chapter berapa?
Akan sampai chapter ni lah. Alright. Chapter ni akan agak panjang. Dia punya slides, if you tengok kan ada 100 lebih. Kita baru cover that previous chapter. Okay. Previous chapter tu yang berkenaan dia punya ni lah. Introduction to computing. Yang tadi logic gate and so on. Yang this one is the microprocessor tu. 86 kan. So yang this one you akan belajar about the architecture of the CPU and then baru you learn about the assembly language after this. Okay, so dia akan masuk setakat this chapter lah. Yang kalau ikut you punya slide tu ada yang sampai ke slide yang yang ni lah, yang sekarang ni, yang I tengah ajar ni. Alright, kalau kita pergi balik kepada slide study. Okay. This slide kan. So dia ada sampai ke 118 ni. Alright. So sekarang you berada sehingga this one, 53. Okay. So you akan cover this slide. Okay, yang chapter ni, okay, this one, the 86 microprocessor and yang previous tu, introduction to the computing. Okay, so that one that will cover for your test 1. Sorry, kita dah pergi sampai mana ni? Sampai alright, I will continue for few more minutes and then we will stop. Okay, code segment. Okay, tadi kita dah discuss about the code segment. Okay, so we look here. Kita look to the data segment. Okay, if we look at this program, okay, assume a program to add 5 bytes of data, such as 25, 12, 15, H, 1, F, and 2B. Okay, so dekat sini kita ada data and code are mixed together. Alright, so ni dia punya code, move ni dia punya code, and data, okay, yang this one lah. Okay, AL dengan 00 ni. So these are the codes and the data. Okay, and then if the data changes, the code must be searched for every place it is included and the data retype. From this arouse the idea of an area of memory strictly for data. Okay, so sebab tu sebelum ni data and code are mixed together. Alright, so dia mix, dia bercampur lah. Alright, so kalau data change, kalau data bertukar, alright, the code must be searched, okay, for every place it is included, and the data mesti also di-type balik. Okay, so sekarang apa yang dia buat is kena ada satu segmen khas untuk data sahaja. Alright, so dia tak perlu nak mix dengan code tadi. So sebab tu adanya data segment. Okay, so the data segment uses register DS and an offset value. Okay, okay, so assume that the data segment offset begins at 200H. The data is placed in memory location like this. Okay, so they start with the 0200, okay, up to 204. Okay, so that's the data. Okay, so sekarang ni maksudnya you akan panggil lah. Alright, so the content of AL sekarang ni berapa? Alright, so data dalam ni, so this is how you call the DS. Okay, so at the location of 0200, okay, so you have 25. Okay, and then 0 add with 25, it becomes 25, and then you add lagi dengan 201, so you add dengan 12. You add, and add. So maksudnya you sum up all of this lah. Alright, so if you sum up all of this, so berapa dia punya value? So you just sum up in terms of hex, right? So dekat sini you ada F. Okay, you ada F, and then you ada B. Alright, so of course lah dia akan jadi nombor yang agak besar lah. Alright, so F is 16, F is 15 and B is 11. Okay, and then you add dengan 5, 5, 10, 12. Okay, so kalau you add, you dah ada berapa? Okay, 15 plus 11, you dah dapat 26, 36, 36, 36 and 38. Okay, you dapat 38. So dah lebih 16 kan? So 2 kali 16 you dah lebih. Alright, so 16 and 16, so you kena bawa 2. Alright, so 16 and 16, 32, so you akan tinggal 8 dekat sini. You akan tinggal 6 kat sini. You ada 38 kan tadi, so you akan tinggal 6 and then 2. So 2, 2 and 2, 6, 8, 9, so 98. Alright, so you punya answer is 98H. Okay, so the offset address is enclosed in bracket. Okay, so inilah macam Dan macam CS tadi juga, this is the offset address lah. Alright. So yang belakang ni is the offset address. Kalau the logical address tadi, they contains these two information, kan? Depan ni, okay, and then yang belakang ni. Alright. So kalau you tahu what is your DS punya content, what is your DS punya address, so you will tahu dia punya what we call the physical address. Okay, the physical address. Okay, if the brackets were not included as in this one, so dia akan sama juga macam tadi. So AL ni akan jadi 200 lah. Alright. Okay. If the data had to be stored at a different offset address, the program would have to be rewritten. Okay, so kalau you nak shift tadi, data tadi dekat tadi content is 0200 kan. Nanti kan you nak tukar that data tu, tukar kepada content lain. So you kena rewrite balik the program. Okay. Tapi kalau tak nak rewrite, macam saya cakap tadi, kita kena gunakan pointer. Okay, kita gunakan pointer untuk hold that. Okay. So macam tadi, saya tadi lah, yang ni saya dah discuss tadi. So kita kena tu balik. Alright, so kita kena cara dia is kita pakai pointer. So sekarang ni pointer sekarang ni is BX. So BX ni akan hold the value. Okay. So dalam BX ni ada 0200. Okay. Tapi kat sini kita nak panggil the address of 0200. Apa yang terkandung pada 0200. Macam tadi. So kalau ikutkan kat 0200 ni ada this one 25. Right. So this value 25. Okay. And then sama juga macam konsep tadi lah. You nak increment that. So you increment that one by one. Dekat sini, you tak payah nak tulis macam ni. Alright. You tak payah nak tulis macam ni lah. Alright. So, the other way, you boleh write macam ni. Macam ni. Sama je. Okay. Sebab yang ni dia akan jadi 200. And then 201. And then 202. And 203. Okay. So that's the other way you can write the program. Okay. Okay, so ni physical address dengan offset address. Okay, tadi kita dah discuss. Okay, kita tengok ada few example. Okay. If DS, okay, 7FA2 and the offset is 438E. Okay, calculate the physical address, the lower range and the upper range of the data segment. Okay, and then the logical address. Okay. So logical address tadilah. So DS double dot apa tu? Double dot ni lah 438E. So kita dah dapat logical address. So ni lah dia punya logical address. 7FA2 double dot 438E. Okay, this one. Okay, and the physical address kita kena tambah 0 at the back. Okay, 7FA20 and tambah this one. Alright, so kita akan dapat what is the physical address. Okay, lower range, you tambah 0 kat sini and then you tambah dengan 000. Okay, so you akan dapat 7FA20 lower range and upper range you kena add dengan FFFF. Okay, so you get this answer. Okay, look at another example. Assume that DS register is 578C, okay, to access a given byte of data at physical memory location of 67F66, okay. Does the data segment cover the range where the data resides? Okay, so macam mana you nak tahu? Dia cover tak data ni? Okay, so nak tahu, you kena tengoklah dia punya lower range dengan upper range. Kalau that data within that range tu, so dia cover lah. So macam ni nak tahu dia within that range. So you kena buat macam tadi lah, you nak cari range dia. So you can cari lower range, maksudnya 578C0 ni lower range, right? And then upper range 578C0 plus FFFF. Okay, you try tambah with that one. Okay, so you akan dapat lah the upper range 678BF. Okay, ni 67F. So dah lebih daripada 8. So maksudnya tak termasuklah dalam that range. Okay. So dia tak boleh cover. So dia tak boleh cover, so you kena tukarlah you punya DS register tu nak untuk cover. Maksudnya you kena put the higher value over here. Alright. Sebagai contoh, you buat you change 5 ni kepada 6. So 678C0. Okay, 678C0 and then you tambah FFF. Okay. So, you tengok dia punya lower range actually 678C0 and then upper range you tambah tadi lah. So, you tambah tadi dapat berapa value dia. So, dia akan from my initial assessment dia boleh cover lah. Okay, that value. Okay, clear?
Okay.
Alright. So maksudnya dekat, kalau macam saya tukar tadi 678C0 you tambah dengan FF dia akan cover lah. So dekat sini yang belakang jadi F ni kan, F tambah C 15 campur 10 by 12 15 campur 12 27. So 27 minus 16 berapa? 11 B kan. Sini B. Kita tambah 1. So 16 tambah 8 24. 24. So tinggal 8 lah dekat sini. Okay, so you tambah 1 dekat sini. So 8, so tinggal sini tinggal 7 and then dia akan jadi 7. 778 BF. So dia cover lah sebab dia punya range. Dapat ini yang upper range, lower range dia yang this one. Okay. Alright. Okay. Alright, so I stop here for today. Okay, ada sebarang soalan? So I see you again on Thursday.
Okay, Doktor. Thank you.
Welcome. No questions. So let's turn on the camera so we can take a picture together as usual. Okay. Okay, so I count from 10. Hawa angkat tangan. 10, 9, alright, 8, 7, angkat tangan, tak ada gambar. 6, 5, 4, 3, 2, and 1. Alright, angkat tangan. Okay, thank you everyone. Alright, see you on Thursday. Okay.
Thank you, Doktor.
Okay, bye-bye.
Thank you, Doktor.
Bye, Doktor.
Thank you, Doktor. Doktor, saya ada soalan.
Apa dia?
Saya ada soalan.
Ada soalan? Soalan apa?
Yang tadi tu.
Apa tu?
Yang mana?
Kan dia tukar daripada decimal ke binary. So kita
Quiz tadi lah.
Decimal kepada binary, yes?
Okay. Lepas tu kalau jawapan dia dapat 7, maksudnya 0, 1, jawapan dia 101, lepas tu 0011. So kita kena cukupkan dia dari 16 bit ke?
16 bit kalau dia minta dalam hex lah. Tapi kalau you pakai kalau you pakai komputer, tadi yang tadi kan you nak convert kan, kalau dia request daripada tadi decimal kepada binary, 0101 lah, alright. Tapi kalau dia request daripada binary kepada hex, okay, yang tu yang base 16.
Oh, so maksudnya kalau jawapan dia, kalau nak tukar daripada decimal ke binary, kita buat yang bahagi 2 kan doktor? Bukan buat yang tadi tu doktor cakap sekejap, okay. Doktor tengok yang quiz tadi.
Quiz tadi, jap. Tak puas hati ke dengan quiz tadi?
Bukan, kita tak faham.
Tak
Saya
faham.
bahagi 2 juga.
Saya pun bagi 2. Sebab kan dia daripada decimal ke binary. Kalau yang doktor kata 8, apa tadi 83 tu boleh ambil nombor tu bukan untuk decimal, bukan untuk hex ke doktor?
Sekejap, yang untuk hex tu yelah, untuk hex you kena ni convert daripada apa tu, dia kena convert ke binary dulu, and then binary baru tukar kepada decimal. Itu cara slow lah kalau you pakai, you nak pakai apa tu, macam mana?
Tadi 83 base 10 doktor ke binary, bukannya hex ke binary. Kan?
83
decimal ke binary kena bagi 2 kan. Tapi yang tadi tu jawapan 100011 tu, yang tu bukan hex ke binary. Tadi 83 base 10 kan.
Okey, jap. Saya tengok balik. Sekejap
Okay. Sorry doktor.
Okey, jap. Mana betul lah. Betul. So,
Tapi doktor, saya tak boh kosong-kosong kat depan nak bagi cukup bit. Tak apa
dia?
kan? Saya tak, kan dia 7
bit. So jawapan dia berapa?
Jawapan dia kalau tambah kosong depan 0101 0011.
So dia punya, dia punya tu is, dia kena pecahkan kan. Tadi berapa value tadi?
83 10.
83. So 83 berapa? 64 kan? 64 kan yang paling tinggi.
Betul? Betul.
So 64. Sekejap. Saya tulis sekejap
Betul lah. Tu pakai manual punya kira. Kita pakai lagi.
Okay. 83 kan?
Betul?
Betul.
Lepas tu 64.
So 64. Okay, lagi?
32.
Tak ni?
32.
32.
Sekejap, tinggal berapa ni? 19 kan?
64. Dah 83 tu 64.
19 kan?
19.
16 lah.
Betul?
Kan?
Betul.
So 3, 2, 1 lah. Kan? Tak?
Betul.
So yang ni 220. Yang ni 221. Yang ni 224. Yang ni 226. Kan? Betul tak? So 1, 0, 1, 0, sorry. 4, 3, 2. Okay. Macam tu.
Ya doktor. Betul.
Doktor, kalau tak buh kosong kat depan tak apa ke?
Boleh. Memang tak boleh kosong kat depan, tak apa.
Oh, kalau boleh bubuh, kalau nak bubuh pun boleh je lah.
Tapi dia tak akan baca lah zero tu.
Oh.
Okay. So dia punya ni 0, 1, 0, 1, 0, 0, 1, 1 lah jawapan dia. Awak buat yang ni?
Ya.
Okay, nanti saya inform pada hari Khamis nanti.
Okay, Encik Doktor. Sorry kacau Doktor.
Terima kasih doktor.
Okay, thank
Doktor,
you.
saya nak link YouTube untuk week 2, week 3, week 4.
Sekejap. Last week.
Doktor baru bagi week 1.
Alamak, last week saya lupa lah record yang satu. Sekejap.
Alamak.
Minggu lepas saya lupa lah record.
Okay,
Awak tengok button record ada tak kat situ? Kalau sekarang ni ada button record kan? Ada lah. Yang kena ingatkan saya kalau saya lupa record saya tekan record.
Karakter.
Okay, minggu lepas tak ada, tapi minggu yang first tu ada lah. Sebab minggu lepas kita ada satu je kelas kan yang 1 hour. Okay, yang before that ada, nanti saya upload yang tu.
Okay, thank you doktor.
Okay, thank you. Alright. Okay, take care. Okay, bye-bye.